In this question, we are looking at solving second order homogeneous ODE using Laplace transform. We're given y prime prime plus 3y prime plus 2y equals to 0, and given some conditions that y of 0 is equals to 1 and y prime of 0 is equals to what, 0. Now, we need to, as we did in the other question, take the Laplace transform of all these terms given here. The Laplace transform is just something as saying Laplace transform of f prime prime of t, y prime of f prime of t, and small f here. You see all these things are small f. So when you deal with that, when you have that in mind, you know that y prime prime would be just like saying the first thing you write is capital Y, next small y and small y, and the very first y is a big Y as I mentioned earlier now. Then this one will be y of 0, y prime of 0. Next, because we have prime prime here, it will be to start from s square because there are two prime. That's the two you are seeing here. The next one will have power s power 1. The next one will have s power 0. See the pattern, right? In that case, and it will be minus and not plus. So because of the prime prime, x square, x, and s power 0, you get. So because of the prime prime as well, our y prime, y will end at 1 prime. So if you have 2, you have to end it at 1 prime. So you might start with y of 0, y prime of 0. And if there was 3 prime here, it would have been y prime prime of 0 to end there. Get? And assuming there were also 3 prime, this one would have been s cubed, s square, x, and then no x. So but in this case now we have prime prime, s square, x, and no x. And so moving further, we know that y of 0 was given as what? As 1. And we know that y prime of 0 was given as 0. So this thing is 0 now. That's why you're not seeing it on this side. And y of 0 is 1. 1 times s is what? S. So that's what this thing gives to us. Now, Laplace transform of 3y prime. 3y prime, just do y prime separately. Is what I said before. This is 2 because of this prime prime. This is prime now. So we only have s to the power 1. See that? So s to the power 1 times capital Y minus y of 0. So in this case now, because of just 1 prime, we don't have any prime here. Here we had 2 prime, we had 1 prime here. So having done this now, y of 0 was given as 1. See it as 1. So when you say 3 times sy, you have this. 3 times 1, you have this. The Laplace transform of 2y, if you do it, you have capital Y. Please be putting y of s, so don't leave it like that. So capital Y of what? S. Okay, having done that, we'll go back and replace everything here by what we have gotten. So I will replace y prime prime by s square y minus s. You replace it there. Then replace y prime by 3sy minus 3. Replace y by 2y. When you have done that, to arrive at this place, you have to make sure that you assemble all the y's together. The point is to make capital Y the subject of the formula. So when you make capital Y the formula, from that thing you did before, because it's not written here, but I believe you understand. If you don't, you can ask question. So when you make y subject of the formula, you have this. You have this. Remember, this thing now is from here, when you must have replaced everything with these things you got here. So you solve, you have this. Now you need to apply partial fraction. Partial fraction. How do we do that? The same way we did the other one. But then before we go into that, we need to find out what this denominator is composed of, whether it is factorizable. That's whether we can put them in brackets. If you work on this now, you will get this. You will get this. Please show work when you are doing this. Show you working in exam how you arrive at this. So partial fraction. We'll proceed with the partial fraction. S plus 3 over, instead of s squared plus 3s plus 2, we have it represented or replaced by this. So you do your normal a over this plus b over this. That's the denominator. So when you have done that, you multiply by the LCM, which is always this one. Multiply it out. This multiply by the LCM, you have s plus 3. Multiply this by the LCM, s plus 1 will cancel. We have this s plus 2 left. Multiply the whole of this by the LCM. We have s plus 1 left. When s plus 1 cancels out from there, you have s plus, sorry, when s plus 2 cancels out from there, you have s plus 1 only. So to get all these things now, we need to put s as -1 first. So I will eliminate b. If you put -1 here, you have -1 plus 1, that's 0. So if you put -1 here, you have 1 times a. That's this one now. You get. And remember, there was something this side. That's this thing now. Here now we put -1 here. -1 plus 3 should be 2. So you see that we have 2 equals to a times 1. This thing now, this place. So a is equals to what? 2. Repeat the same thing for b. That's, you have to make sure that in this case now that your s is equals to -2, so that we can eliminate what? A and get our b. When you do that, you have b equals to -1. So now you have gotten your a and b. Replace your a by 2 here and your b by -1. You have this. So instead of writing -1 plus -1, you can bring out minus like this. So if you do the inverse Laplace transform, you know 2 can go out. So exponential is still taking this exponential minus t, because this thing is +1, so it becomes -1t. Because this thing is +2, it becomes exponential -2t. The minus is still there, this minus is still there. Yes. So this is from Laplace transform of 1 over s plus 2, 2 over s plus 1. If you check the table, that this thing is synonymous to something there in the table, and that's exponential 80.